This is the first episode of Mind Tracking podcast called Becoming a Theoretical Physicist. For this podcast, I have with me Nesta and two of my course mates, Sean and Saba. We are doing a theoretical physics masters at the University of Edinburgh, and Nesta is doing a PhD in the Department of Informatics, but still it's about the causality of space-time.
Just say I'm doing mathematics.
You're doing mathematics, okay, but still physics, mathematical physics, right? So
mathematical physics.
Mathematical physics, that's right. So before I go into any questions, can you guys say where you're from and where you studied before the University of Edinburgh?
Yeah, shall I start?
Yeah.
So I am Dutch, I'm from the Netherlands, and I did first 4 years of physics undergrad at the Radboud University in Nijmegen, and then I did my master's there for 3 years in mathematics, also at Radboud University.
Can you just say the name slower?
Radboud University.
Radboud.
I won't touch it.
If it's also relevant, before that, before university, I did 1 year of engineering physics, because the high school thing in the Netherlands is a bit weird, so I couldn't go to university. I had to do this one sort of like bridge year of engineering physics.
So you were 17 at that time?
I was 17 I think when I did engineering physics, and 18 when I started my undergrad.
Okay. Did you do any international baccalaureate?
No.
Okay, just then.
Yeah.
Cool. Saba?
My name is Saba. I'm from Afghanistan and I did my undergrad at Swansea Uni in Wales. Before that I did just international A levels. I just did 4 years of undergrad in just physics. I did a foundation year and then moved on to just doing 3 years of undergrad and then applied here.
So it was an international school then in Afghanistan?
No, so I grew up in the UAE in Dubai. So I did I went to school there, did my GCSEs and then did my A levels. 1 year of it online and then the second year of it as part of an institute, and then gave the exams. Yeah.
Oh, quite complicated.
Okay.
So Afghanistan and then Dubai.
Yeah.
And then Swansea and now Edinburgh.
Yeah. Well, I haven't really lived in Afghanistan. So
Okay.
I'm from there. Yeah.
So the most exposure you have is of
The UAE. Yeah.
the UAE. Okay.
Yeah.
United Emirates. Okay.
Yeah.
Well,
Sean?
I'm Sean. I did my undergrad at York, but I'm originally from Wiltshire in England. So did undergrad in physics, just plain old physics. Then spent 4 years working as a software developer down in London.
4 years.
4 years,
Oh,
yeah.
wow, okay.
And then missed physics and decided to do my masters.
Nice.
Me too, I have some of that as well.
Yeah.
So I'm Chris. I did my high school in Romania and then went to Imperial College London for my undergrad in physics with theoretical physics. Spent 2 years as a junior data scientist, and now I'm back to physics because again I missed it, and I missed the theoretical physics. Okay, just theoretical physics. Okay, that's what I missed. No labs.
Yeah, I think we're all.
Do you all hate labs?
I mean, it's probably a reason to do it.
Yeah.
Physics.
Cool.
I do miss some of the light experiments though. They were quite cool.
You mentioned before. So how many of those did you do?
Maybe a couple, not loads, I have to say. Every week, and we had to do all the data.
Every week. Wow.
Yeah, data
Okay, no,
analysis
that's
and
quite a couple. Then.
Yeah, we did quite a few. Yeah.
Maybe 4, 8. What's?
So what labs?
Different labs.
Every week we did a different one, and then there was probably
Wow.
10 weeks of uni in every term. And I think we did in the first year we did labs in both the terms, and then second year we did. I was part of the theoretical side, so we just did some mathematical work.
Okay.
We replicated graphs of the neutrino stuff from the Super Kamiokande.
Okay, that was the last year.
That was the second year.
Just second, okay.
Yeah.
Oh, great.
Yeah.
Getting on the real world stuff.
Yeah. That was
Good. Okay, so before I move on to the questions, I'll just say the motivations for this podcast. So there are quite a few. The first one would be answering the question, why do we do what we do? granted, following a theoretical physics career is the most important decision maybe in all of our lives up to now. This career path is laden with false expectations. That's what I feel.
Yeah.
And we talked about this before,
Yeah.
Saba. So another one would be that sometimes when you're quite far away from the starting point, it's nice to look back and see what you learned. And also to give an inside perspective of what it takes to become a theoretical physicist, mainly focusing on the things that you can find out only if you're inside the system. So those are the motivations. So the first question would be starting from the beginnings. As a child, did you first become interested in science generally, or did you have a knack for physics stuff? Or up until high school, did you feel that there was a difference between your passion between science and physics? Physics maybe because theoretical physics kind of it branches out a little bit later. So
For me personally, I don't remember me being interested in science at all before high school. So
before high school,
Yeah.
okay.
Yeah.
Yeah, I think I can relate a little bit. I was up until 14. I think I just liked the cool images on TV, and from 14 years old onwards, I started working towards competitions, and I kind of, actually my mother was the one that at 14 years old, it was a summer holiday, and she came to my room and she said, now you need to excel in one thing, pick one. And I just thought, okay, I like mathematics, I kind of like this cool images on TV, maybe I should pick physics. So that's how it started.
No, for me it was always maths and physics.
Okay.
Pretty much since I was initial kind of primary school.
Right.
I think I was always more interested in physics classes back when I was we were doing tiny little circuits with little light bulbs and just a basic battery. And then that and maths kind of throughout my life really.
Cool.
Yeah.
Okay, so you were never the kid that would be doing anything science, or if it's biology, if it's chemistry, you're always into that sort of stuff. And
I never really cared about chemistry and biology as much.
Me neither.
I love biology and chemistry.
Hence, that's why you're doing some of it now.
So I wasn't a massive science person as a kid either. I was more into humanities, I would say.
Okay.
And
as a kid or up until high school?
So up until high school, I liked the sciences and I was fine with it. I did well in them, but I didn't really consider it as a career choice or as something that I would pursue until high school. And I went through many phases. I was engineering, medicine, this, that. And then I kind of stumbled upon physics and I thought, okay, this is cool, I can do this. But I was very much interested in biology, chemistry. They were very cool. Chemistry specifically is always really cool,
We have some variety.
It's interesting actually because I was never really that into chemistry or biology, but the interest I have in physics have actually led me down a more chemical or more chemistry kind of path in the end.
Do you remember what was the first major event that made you want to pick physics? I already told mine, it's my mother.
For me it's not really a particular event. So I think I started liking physics in high school. Physics class was always pretty cool. I had some good physics teachers. Math I wasn't really into, didn't have good teachers necessarily. I mean, they were kind teachers, but they didn't make it super interesting. It was just boring, usual high school math, which is not too interesting. Actually, I also did quite bad in my final exam, so...
Right.
And then physics was...
Was it because you were just interested in something else at that time, or you just found it
remember,
boring?
honestly,
Okay.
I suppose,
Very interesting,
physics went pretty well and decently well. And then, so at the end of high school, you had to kind of choose, what are you going to study after high school? And I sort of more or less stumbled upon physics. I was like, okay, I like physics. So I had the choice of either doing the engineering physics thing, or I was thinking of doing something like concept art, like game design. And in the end, I chose physics, and the rest is sort of history.
Cool. So.
I don't think there's like a defining moment. I think a lot of some of the, and again I would agree with the teachers. It wasn't a lot of fun, and physics in high school as well. I don't think is too fascinating. It's a lot of Hooke's law, a lot of stuff
linear
like
stuff,
power, work, So it wasn't like the most exciting thing. But I think what gave me perspective was watching some documentaries. I really liked Through the Wormhole with Morgan Freeman. So that kind of gave me perspective. I'm like, okay, well, physics can do this. This is cool. We can do this.
Okay, yeah, we're gonna touch upon that for sure.
Yeah, actually related to that, like I want to say on YouTube as well, there's like some stuff.
Yes.
I don't know if you guys know this. There's a channel called Melody Sheep, and they make like sort of music remixes of like sciencey stuff. So they use like clips of Through the Wormhole and stuff to make like a song out of it.
Okay.
And one other video sticks out to me in particular, which is called like Quantum Physics, Welcome to the Matrix or something.
Oh, nice.
And it's like this super mystical collection of clips of like consciousnesses, influencing matter, and that intrigued me so much in high school.
So it was interesting because you say about consciousness and you wanted to do some art. You know, it's a little bit mystical. That's a very mystical, pseudoscientific video, but it was so sort of intriguing that I thought that was like legit physics at the time. You know, rap battle or something.
No,
it's an actual song.
No. That's just like a collection of clips of people like talking about consciousness.
Okay, so it's not song, or they do songs. And
this is unrelated to that channel.
Right.
Yeah. But that was just one particular video that I still like revisit sometimes.
Oh, cool.
Nice.
Okay.
To let yourself know where you.
Yeah.
There's also, I feel like Vsauce is quite good.
Yeah.
Channels like
It's
that.
very intriguing.
Maybe we could reference some of them. So quickfire,
Very
Veritasium, Vsauce,
Yes.
60
Vsauce.
symbols,
Minute physics.
Minute
Minute
physics.
physics is
Yeah.
really
3 blues,
good.
1 brown.
Yeah.
I've heard of that. I've never really.
Oh,
He's great.
There's what is it? The two brothers that do the videos. I can't remember the name of it, but they're brothers. One does like more literature stuff, and then
Vlog Brothers.
is it?
Yeah, Hank Brown.
Yes.
Hank Green,
that's
sorry,
it.
Hank Green and John Green.
Yes, because he wrote the John Green book.
Wait, is it the Sci something?
Yeah, John Green's
Show?
brother is Hank Green. He does the science side of the videos.
That's why they look so similar. I
They
always.
they are brothers. Yeah.
Gosh.
Twins even.
Are they? I
But
didn't know
I
that.
don't.
They're what? Sorry, twins. Maybe yeah. Yeah, one is doing the history stuff.
History,
the other-
literature, philosophy, myths. I love the myths one. They're so good.
Yeah, and the animations are also good.
Yes, they are. They are really good.
Yeah.
Those are good. There's one on Vsauce I remember that said the video is about what if the moon was a disco ball.
Yeah, I
It was
remember that
epic.
one.
It was so good.
I remember that
Yeah.
one. It's just, I think it's done in Blender or something.
I have no
yeah.
idea about.
Yeah, that was cool.
I got mentioned Kurzgesagt.
Yes, also very good.
Yeah.
That name. Okay, I'm gonna put it on.
On
video. Kurzgesagt or something like that.
Kurzgesagt.
Okay.
Okay.
Yeah. You're the person that
It's
should
German, but it's close.
close.
Yeah.
Also, another documentary that I just want to mention, which is also very like pseudoscience-y, mystical.
If it does the job, it's
Yes.
It convinced me to do it.
Yeah. It's good enough.
It's called What the Bleep Do We Know? Down the Rabbit Hole.
Okay.
It's
Yeah, I'm gonna add links.
I would recommend.
Okay. Down the rabbit hole.
Down the rabbit hole.
When you're high or when you're not high.
Either works, you know.
Whatever gets you there.
Yeah.
Okay.
Whatever gets you through.
Nice.
Back before university, what was your exposure to physics like? Did you go to any summer schools, competitions? Did you own stuff that is physics related, maybe like a lab of some sort? Were you doing your own projects? Summer camps, reading popular books? What were the activities that you were most involved in that had theoretical physics I will just want to put focus on the theoretical physics.
Yeah, of course.
Yeah, what?
I guess for me, so my sister went to Imperial College, and they do lots of public lectures. Or they do a fair number anyway. So I think for me, actually, the biggest thing I was doing was going to those, because you know, whenever a decent one was on, she would always stay at the house, we'd always go grab a dinner or something. You know, so train right away for me to get to Imperial College, so it's not too bad. So I must have gone to about 4 or 5 of those in like 2 years before I then went off to college myself.
That's cool.
So that was pretty cool. And obviously, while I was there, museum, because you've got
Yeah,
to
yeah,
decide
that's
museum in
right.
London. Yeah, those would be kind of like, I think, the 2 biggest things, especially that I can remember.
So public lectures.
Yeah, public lectures.
So mostly you were just doing school stuff, and every once in a while you were going to a public lecture. How often would you say?
So I think in total though, I went to about 5 or 6.
5 or 6.
So every 2 or 3 months.
Every 2 or 3 months.
Over
Okay.
about a year and a half, yeah. Throughout my age.
No, that's good commitment. What about books in your free time?
Oh, books, yeah. So I used to, when I was about I guess 14 to 16, I was really into like pop sci physics books.
Right.
What is his name? The guy that's in DV,
DV?
yeah, it was a band. He was a pop star for a bit, and then he became a theoretical physicist. Lectures at Manchester. Very kind of like public kind of British TV guy. His name's
Brian Cox?
Brian Cox.
Yeah.
Brian Cox, okay.
So I read all of his books.
I didn't know he was in like a
I
band.
didn't know that either.
Yeah,
He
he
looks
was in
a little bit
famous
very-
British band.
I did not.
Like, yeah,
Very
huge-
famous.
Yeah, huge band in the
Oh.
80s, like in Britain at least. Everyone would have heard of them. Like your mum, your dad, would definitely heard of them.
Right.
Yeah, so I read all of his books. Once attempted to read Stephen Hawking's Brief History of Time. Probably why I'm not that into cosmology. It's a very dry book. And yeah,
Oh, that's unfortunate. I just bought it and I wanted to read it.
I mean, if I tried to read it now, I would probably
Yeah.
make it a lot further. But when I was like 40 or 50, I think I was being a bit ambitious. Other than that, actually, there was a very influential book on me, which was a book called Professor Stewart's Cabinet of Mathematical Curiosities. Obviously, it's not physics, it's maths. It's a great little book. I bought it when I was about 12 or 13, and I think got through it in about 2 days. It's like a few hundred pages, just short.
A few hundred pages.
Sorry, 200 pages, not a few hundred pages. But like it's just like a bunch of like little facts and like short stories, a few jokes, all like mathematical. But it's a really good way of sparking like interest in somebody who's like the teenage. And like he's released about 4 or 5 others now. I've got them all, even though I've only read that one. I've dipped into the others, but that had a huge effect on me when I was in like 12, 13, that kind of
That sounds
age.
awesome. So can you say the name again?
Yeah, it's Professor Stewart's Cabinet of Mathematical Curiosities.
Cool.
That's hard to say.
Yeah, it's hard to remember too.
That's super cool. Yes, sir?
Yeah, I had some things, not as much as you did, I think. There was one book I can remember, which was A Brief History of Infinity or something it was called, which was, now that I'm thinking about it, it was quite interesting, like a history of how the concept of infinity sort of evolved. It was not really a math book, but it was a history of math book.
Was it Lao Tzu mentioned somewhere?
I don't remember. It's too long ago. And then we had in high school for like 2 years. I had a really good physics teacher. He was a young guy, and we did some after school stuff. But it was supposed to be like a legit project, but we never actually got around to it. It was more just like he just was talking a bit about physics, and. At one point, he showed us a textbook on special relativity and on like time dilation and that sort of stuff, and that I thought that was really cool. I didn't understand anything what was written there, but I think that must have sparked my curiosity.
Just a question on that.
Yeah.
Is anything related to relativity something that you do in high school at all? Or
No,
not even as knowledge.
I don't think we
Just
have-
written somewhere and you have to remember it for an exam or something.
I don't think we actually did any special.
Interesting.
Yeah, I think here we did touch upon it.
Yeah.
Like in a, we didn't do any maths related to it,
Yeah.
but I think we did touch upon it in a, this is something that exists.
Mhm,
Yeah, but not anything to do.
mhm.
Another memorable moment is we have eventually after I think the first 2 years of high school you sort of get 2 different levels of math.
Mhm.
So you have A and B, and A is like very sort of applied, and B is like more like calculus and like more advanced stuff.
Mhm.
And so the first lesson of this B math course was like the quadratic formula.
Oh, okay.
And I was like, whoa, that looks so cool. we're like looking at some cool equations,
yeah.
and like, I remember like sitting in that classroom and like sort of being like,
Quadratic
in
equation.
awe
Oh
of
my
this
god.
equation.
Plus minus square root
It
of
looks so
cos.
impressive if you've never seen that before.
Yeah.
Was that at 14 or?
Yes, I was 14 then, I think. Yeah.
Gosh, wow. Okay.
Special relativity at 14?
No, special relativity
Oh,
was
that
like,
was,
I think
okay.
later.
Yeah. And it was just in a textbook that your teacher mentioned. It was
Yeah,
not
we
something,
didn't
yeah.
study
Okay,
special relativity.
okay.
yeah.
I mean, the exposure is still.
Mm.
Yeah.
So?
I don't think there's not a lot in terms of actually getting my hands dirty and actually experiencing a lot of physics, which is kind of sad, but there was just not a lot of things that were offered or around me that I could have access to. So everything that, you know, the exposure that I had to physics or theoretical physics was again like media that I could consume online. So again, I will come back to through the wormhole with Morgan Freeman. Like he really did it like to get me into the field.
Okay.
Yeah.
So you're gonna talk very well about the physics marketing that's
Yeah.
being done.
I don't know if it was his voice
Mhm.
or the actual physics though. It's debatable.
Good
Yeah.
question. So in my case, I mean, after that summer holiday that my mother told me that I need to study something,
Big one.
I started doing personal. I mean, I had a private tutor in physics. I wanted to attend. I went on to attend multiple competitions, Olympiads. I was never like anyone on the national scene, but you know, I won prizes on the regional and whatnot, and some national competitions. But I was always very much into the philosophy of theoretical physics. In Romania, we do a lot of very maths heavy stuff. So we do alternative currents also.
Okay.
We use integrals and the differentiation in 11th grade. So that's when you are 17 or something. We also do relativity in the final year. So we have a lot crammed in. I don't want to praise that. Oh my God, Romanian educational system is so good. No, not at all. Because it's good for people that are interested. So for me, it was perfect because I was exposed to so many things through just my experience in high school, but on my own, I was reading compendiums, I was reading popular books. The final volume I read it just before university for volume 1, one of the best books that I've ever read. George Gamow. We had another David Resnick and David Holiday. Another textbook on physics. So I was kind of picking the textbooks from university and just reading through. And I was so much into, because in Olympiads you're always asked very interesting questions. That's what I loved. And this is what I was left with from high school. This is what I knew that I wanted to do. So for example, a few days earlier, I think I sent Eunice the theoretical minimum article by Boris Ayofi. So I don't know if you've heard of theoretical minimum. Yeah, so it was let's say an unofficial school that was headed by Lev Landau, and he was working at the time in the University of Moscow, but he was leading some seminars on his own, and he only allowed people to attend the seminar if they went through some of his exams made just by him. And so just to give you an idea what were the questions like in the exams, there were I think about 8 different exams about everything, matter, waves, quantum mechanics, everything in one place. So I'll give you this question. It's one question that I love. I read it in my first year of university, and ever since I tried to imagine how the solution would be.
Okay.
Right now, I cannot imagine.
Mm.
Still cannot imagine. So you have a tube of radius r, and an electron goes into this tube, right? Then you take the tube, you bend it
Okay.
with radius r at an angle alpha.
The
Right.
same radius r.
Yeah. No, a radius r much bigger than the radius of the inner tube.
Okay.
And then you bend it back, you align it back.
Yeah.
What's the probability that the electron will come out of the tube? Boom! Can you imagine?
But
Can
what
you
is-
think
what
of
is this
anything?
bending? What effect has this bending had? That's what we don't know, I guess. Is it?
To be honest, I can't tell you. I can't tell you, you know. I don't know. I thought about it.
Surely there has to be something out there.
The only thing that I could think about is using Schrödinger equation somewhere.
Mm.
But, you know, I feel so humiliated that I cannot even imagine, you know, how to start. I don't,
Yeah,
I cannot imagine any part of the solution.
I guess if the tube's bent, maybe the electron is accelerating, but
Yeah.
that's not even like a.
Mm.
I don't know.
Yeah, because of the direction change. Okay.
Yeah, it might.
I also have no idea.
But you know, so these were the types of questions, similar questions phrased like this you found in Olympiads a lot. It's just, you know, a problem that's worded in, I don't know, less than 30 words and that's
Okay.
it, solved it.
Have you tried looking this up?
You can't find it anywhere because it's, I mean, it's his manuscripts. If somebody published his manuscripts, then you can find the answers. Otherwise, he didn't print
Oh, okay.
the solutions or the problems. It's only through the people that solved them that were passed on and on and on. So
Okay.
people were trying to solve.
Oh, so it's like
And
an
then-
open-ended question that just people, generations of
Ah,
people.
no.
tried to solve.
They were questions that were solvable, and
Okay.
you know, people that would go on if they wanted to attend the seminar, they would ask other people that were already on the seminar, or they, you know, they try to solve the problem just to at least hear what the problems are and then try to solve them because you cannot find the answers anywhere,
Okay.
right? So anyway, but that's just one of the things that really inspired me as a student in high school. I mean, I really difficult, but I loved it. It's great. It's great. Yeah. Apart from that, I owned a telescope and I was trying to do my own observations, whatnot. But yeah, what can you do for you? But yeah, I mean, the biggest thing for sure. Solving problems, hard problems for Olympiads were the thing that made me fall in love with theoretical physics. And I knew at 15 or 16 that this is what I want to do. And you know, this is it. Yeah. So the conviction came from very early. So yeah, that's interesting because I felt like this was supposed to be your answers too. But
But I am the complete opposite. I do not like those types of questions.
I was
at all.
just gonna say, I don't
No
like
way.
questions. I like more just like delving into the.
Yeah, okay, well, at least for math Olympiads, the questions are always you have to be very sort of smart about it. You have to have a smart trick.
Exactly. Yeah, that's what I loved.
Yeah, this is sort of slightly tangent, but there's a parable about the famous mathematician Grothendieck, who's very famous in algebraic geometry. And basically you have a field in math called analysis where it's very tricky. You have lots of epsilon deltas, it's a very technical field. And the problems there are your Olympiad problems, and you just need to find a clever trick and that solves the problem. Grothendieck, on the other hand, was more like a math problem is like a walnut, and if you want to crack it, you put it in some water and you let it sit for a few months, and then maybe you knead it for a little bit, and then after a few months, just the shell comes off and you have your theorem, your solution.
It's horribly efficient.
But it's, in my opinion, that is my way of working, and that is sort of there's a certain beauty to it.
No, that's very interesting actually.
No, I
Very
completely
poetic,
agree.
I'd say.
Actually, any kind of question that has a trick, not even a trick answer. If there's a specific answer, one way to do it, it's not for me.
Yeah.
I want to have something I can actually work through and figure out,
Yeah.
rather than something where I have to just know that and or go down the one line of reasoning that leads you to the answer, you know?
Yeah, so, sorry.
I was going to say, a lot of the times though, physics does use that. I know in our assignments and stuff as well, there's a trick which makes it very easy. Otherwise the math just looks horrible. You can't do it, which is not great.
Yeah, so the idea of in analysis is like the clever trick. Yeah, like you introduce this like number, which is like very weird, and then suddenly makes everything work. Like, there's sort of like this big gap of intuition that you need. And the idea of code technique is that you just set up everything meticulously and slowly, so that in the end, the solution to the problem is completely trivial.
Okay.
Yeah, that's a different way of thinking, and something that I'm not used to.
Yeah.
That's why I found my geometry of general relativity and differentiable manifolds so hard.
Yeah, it is. Well, they're both valid ways of solving problems.
Definitely. And they really do take the time of introducing, all of the theorems and all of the proofs. Sometimes I feel they come out of the blue though.
That's the analysis type of thinking. Like if it comes out of the blue, that's a hint that it's analysis.
Yeah, maybe. Yeah, because if I just read through, I cannot imagine what the next step would be. They need to say in the textbook, okay, and now the Derang cohomology. What? I don't know how. I didn't know that I needed this, and it's so new notation. I don't know. It's confusing, but definitely it's another way of thinking, and I think maybe even more valuable than more potent.
You need both, because not every problem can be solved with this walnut method. There are analysis, you just can't do it in that way. So
sometimes you need to have that one idea
Yeah.
that changes the world.
exactly,
Right?
exactly.
A hammer to.
Yeah.
Not everything can be soaked, I guess.
So even if we start talking about this, what do you think about creativity? So which breeds more creativity? Which approach?
That's interesting.
Do you feel that universities try to breed your sense of creativity in solving problems, or is it just teaching you a lot of stuff, a lot of tools that might be useful later when you actually have the time to think so that the right idea comes?
Yeah, I think it can really depend on the lecturer or on the person designing the course. I do find, I think the kind of the trick way of solving problems is easier to teach.
Yeah.
So I think a lot of people fall back to that for lack of being able to teach better methods. But I've certainly had lecturers or had professors who did try to engender a more creative way of problem solving. They would ask questions. I think actually a lot of them would want people who asked questions related to actual kind of real work, like simplified problems or that kind of thing. And they wouldn't look for there wouldn't be one way to solve the problem. There'd be multiple ways or the kind of that kind of thing. And I think that style of teaching does engender more creativity. But I think it's almost paradoxical in that the trick way of teaching or the trick way of solving problems requires more creativity. If that makes sense.
It requires a lot of creativity to come up with the trick.
Yeah.
To teach, to learn the trick. Once the trick is there, you just have to memorize it.
And I think they have to the not showing us how someone came up with that trick, because it must have taken ages and it must have been a process in itself. When you don't teach that to students, then students start to compare themselves why can't I come up with this? I know I felt that. Why can't I just come up with it? It's so obvious, it's right there. But sometimes
after you look at the solutions.
Exactly. But sometimes even the people who came up with it did a very backwards process from the answer to the question, and it's always it's not a linear process, I don't think.
I actually find this interesting because it's another method, and the process of coming up with a trick solution is never being talked about. Maybe we can actually make a different episode only on that because it's so interesting. What do you actually do? What's your thought process? And I have some experience with
to come up with
and how does your mind work? What do you feel? Where do you go in your mind to solve this problem? It's an interesting topic. It's. Thanks actually for the answers. So, going back to high school, did you have any mentors? If so, how influential were they? And what would you not have been able to do without their input? Mentors.
Interesting question, actually. Nobody comes to mind as like an actual mentor, but I can definitely think of kind of like 4 or 5 teachers of mine who were very influential on me, not in a way that I would say was mentoring, but just teachers who were just genuinely really good teachers, and they actually brought a lot of joy into the subjects, and for kind of like various reasons. I had kind of I had a chemistry teacher back in A level who was absolutely nuts. Like, genuinely, I do wonder if something just wasn't, if she wasn't kind of fully okay, but she was she really had a great way of just making you enjoy being there.
That's
she was just
great.
such a naturally. She was kind of like the kid in the friendship group who's always telling jokes and making the atmosphere relaxed, and if he's around or she's around, then you're always just going to have a nice time. This teacher, she was like that, a teacher version of that, and I think that really kind of having that enjoyment, having that kind of just will to be there, really helps people not only learn but also grow passion. And I said she was a chemistry teacher, and I never really cared that much about chemistry, but I really enjoyed her class. I really cared about her classes. I really worked at her classes because she was such a joy to be taught by. So yeah, and a couple of other teachers who, not necessarily quite as extreme, but similar reasons. All of the teachers I think of when I think of mentors, even if I don't think of them as mentors particularly, they're all teachers who just brought joy to the classroom. They were teachers who you wanted to go to their class.
That's awesome.
Yeah.
So chemistry teacher.
Yeah.
Interesting.
Maybe a bit too much time over the chemicals.
I think I'd agree with that. I think I had a chemistry teacher as well who was brilliant, and I think the way you described it, correct me if I'm wrong, I think there's this the way they taught, I think it was more that they were easily approachable.
Yes.
Right? And
Yeah,
you see
absolutely.
a bit of yourself in them, and a bit of like, oh yeah, if I make a mistake, that's okay, I can just ask. It's not an issue. And made it seem that you don't have to go by the book. So a lot of the times in high school, and especially if you're doing standardized testing, what tends to happen is they teach you the exam rather than teaching you the science or teaching you the subject. And a lot of times that happens, and schools need to do this and are kind of pushed to do this because then there are quotas that they need to fill for students having certain marks, and this kind of pushes schools and teachers in almost the wrong direction about teaching. But this teacher that I can remember, and again this is the same way that I feel about this teacher, not a mentor but a mentor, and also in chemistry. So very relatable and very a different way of teaching, not just stating these facts and then saying do this question where you can't see, touch and feel the subject. She'd bring, without labs, she'd just bring stuff to class. We did a lava lamp experiment which was brilliant with oils and food colouring and stuff like that. It was brilliant. She'd just bring it into the classroom. And I think there's 2 elements, like creativity, A, B, just being able to approach this teacher or this professor, and that helps loads. I also remember an English teacher I had, which I think I read more books in that year that she was teaching me than I have in my entire life. She was super influential, and again, is very relatable. I knew her. I knew both of these teachers on a personal level as well. There was this. I had the feeling that they cared about me in their classrooms, and they cared about the whole process. So I think that's influential, definitely.
Yeah, absolutely.
So it's one chemistry teacher and
An
another
English teacher.
and an English teacher.
Yeah.
Okay, interesting. So still you went into theoretical physics and you have mentors.
Yeah.
You feel that you have a connection with teachers that were completely different.
I have a chemistry related, not mentor, but Yeah, so I want to sort of echo the sentiment that I didn't really have a mentor. So I mentioned the physics teacher before who showed me the relativity stuff. He was also quite young. He was like in his mid-20s, I would say. So that's sort of automatically
Your
makes
age
it
now.
more
Yeah.
automatically makes it more relatable. I did have a good chemistry teacher as well. She was actually like Olympic gold medalist shot put or something.
Brilliant.
That was pretty cool.
Yeah.
So, and she was very kind as well. She was very relatable as well.
So that was mathematics?
Chemistry.
Chemistry, okay.
We're running
Yeah.
team. We're running team.
But maybe now that I'm thinking about it, my uncle is actually a chemist. And he is my favorite uncle.
That's on camera.
I'll send this to you. And like a few times when I was visiting him, he lives in, I think he lived in Switzerland at the time. He worked in Switzerland. He took me to his company and he like showed me around the lab, and that must have in hindsight made an impression on me.
Wow, very cool. So for me, I actually have two mentors. One of them is my mathematics teacher, which was, you could say, I mean, she was tutoring me throughout middle school. Is it middle school or is it before high school? So, we started together, but it was a type of tutoring that we were doing every single day.
Wow.
So it was very intensive, and we grow very close together now. I consider her my grandmother, but she has been very influential in teaching me mathematics and me having a deep understanding of mathematics. I always had an easy time with doing anything mathematics. Never went to Olympiads though, but whenever it came to solving problems, easy. And my second one was my physics teacher from high school, who was, my respects, Professor Roshu, who was he's a very classical person. His sense of culture and his knowledge about physics in general, it's awesome. He always quotes, big people in physics and mathematics and, history. He always made it, such a profound experience just listening to him talk about these people. So I think that played a big role into how close I grew to physics in general. And we were only solving theoretical physics problems. And he made me come into contact with such awesome problems, that has such awesome little tricks that, he played a very, very important role in my going to university to study physics. So, without both of them, I would be in such a different position. I couldn't imagine myself being so fluent in mathematics or physics without them. So.
That's awesome.
So I was lucky, man. I was lucky because it's like mathematics and physics, right? And for you it's chemistry, English, and what about that? Very, very different. So I was actually expecting that this is gonna be an echo chamber, but I'm the only one that's not echoing.
It's nice that there's like some diversity in that sense, right?
No, definitely.
Chemistry, physics.
Oh my, because for me it seems very linear. At the beginning of university I knew that I wanted to be a researcher. For you guys it's like, I didn't really like physics anyway, so I don't know. I mean, it's such a different way to approach the career path.
I think some people realize it maybe a little bit later. At least for what I saw around the people around me, most of them didn't have a clue what they wanted to do after high school, so they sort of just picked maybe the something about the course of the teacher that they most liked.
I think physics is quite common on that kind of thing as well. Because obviously, physics doesn't lead into a particular career. Unless you want to be a physicist. So I think a lot of people pick it because they're interested in it.
But for me, definitely my interest in physics started to bloom in university.
That's why I switched later from
engineering.
Physics
So it was more of I sort of knew I was always more interested in theoretical physics, but because of so there's levels in Dutch high school, so I couldn't go to university, so I had to do this 1 year of engineering physics in order to go to university.
Sure. Just one thing. Question about physics marketing. I really wanted to go into this, and I'm gonna reference you, Saba, right now. You sent me a meme at some point.
I did.
Yeah, and the meme says something like, I joined, I went on to study physics because I thought I'm gonna be the next Einstein, and now, he was like a disappointed face with the Joker.
The clown filters on,
Was it a clown filter?
Yeah,
I thought it was some quantum mechanical
wow.
stuff, and then printed over his face.
And it's
That's
just
an evolving wave packet or something like that.
Wow.
I mean,
Wow. Sure, that's definitely it.
Okay,
the guy's on TikTok. He's a professor of physics, actually.
Is he? Okay.
Yeah. I felt very felt it.
Yeah, hard facts. So, indeed, many high school students go on to study physics, thinking that they're gonna become big.
Yeah.
I don't know if Einstein big, but big. Is that a good or a bad thing?
I would say
I did.
I didn't for me, I didn't think I was gonna be like Einstein, but you definitely are like. At least it depends on the problems you're interested in as well. Like if you're interested in stuff like quantum gravity, that is like
cream of the crop.
You have an idea of like you're gonna do something. It's gonna be awesome. And it's gonna change quantum gravity.
Yeah. That's exactly me, man. That's exactly me. Before university, I knew that I wanted to do gravity. I don't know why. I couldn't explain it. It's such a visceral thing, I want to do gravity. I want to do gravity.
But this came to you before university.
Yeah, before university. That's because I wouldn't have minded to in university just go on to study from first year, third year courses on even if it's hard, like fuck it, I don't care. I'm just gonna do it. I really wanted that, but universities are not so accustoming to people like me. Kidding. I mean, but this is what I really wanted to do. Yeah, that's the feeling at least that I had.
Okay.
Yeah, that's interesting. That you knew what you were.
Yeah, gravity. So this word, I don't know how, it's kind of ingrained in me. I know that I want to do gravity. So even now, going for a PhD, you can also study gravity in so many different ways. I just picked one. After all, gravitational waves, because it's kind of new. It's multifaceted, multidisciplinary, and
What is it about gravity that makes it so?
Because it's an unsolved problem. That's the thing that caught on.
What is it about gravity that gravitates you to gravity?
Oh. Yeah.
I had to.
I think this whole kind of like people going in with much higher expectations of reality, I think up for disappointment. And I think I know I certainly, because I think everyone to some extent has that kind of feeling, right? And I definitely did. And I think it's kind of a bit tough when you get to the end of your kind of like undergraduate degree and you start doing your undergraduate project, and it's so far removed from kind of like the frontiers of physics, like and your decent supervisors, they're going to make it related to their work, but at the end of the day, you can't give an undergrad kind of super complex quantum gravity stuff. You just can't. And I know several people who really struggled towards the end of their degrees because they were like, well, what's the point? I'm not nearly as good as I expected to be at this point, and it was really tough for a lot of people.
So that's talking about the end of the undergraduate. Just important distinction.
Yes, yeah. I think it's odd actually, because I know with a lot of these masters projects we're looking at now, they are a lot closer to what what your supervisors are doing. I know my supervisor wants to at least use the work I'm going to be doing in a research paper.
Yeah.
But I distinctly remember kind of all of the undergraduate projects we had available. None of them were like that. Like a lot of them would be kind of related to the work they were doing. Like my undergrad project actually was very experimental. I was building like a testing device for magnetoelectric materials. So it was at least related to why my supervisor was going to use it. But at the end of the day, it was sticking it in electronics together and writing a front end to it in LabVIEW. It wasn't even close to kind of real research, or I guess it's a part of research, but it was
not what you imagined.
No, it's nothing like what you imagined, you know. And I think that was certainly the case for a lot of my friends, and they all kind of struggled with that.
Note to self for people that are listening: undergraduate projects are not that as great as you think. Okay?
Yeah,
But keep dreaming.
But keep dreaming. Yeah, it's important.
But that's the thing. I think if the kind of projects that we're doing now for our masters are the kind of thing I was expecting to be doing.
Note to self: undergraduate is not that great, but master is.
Yes.
So you can just push through.
But yeah. So I guess that's my take on it. I think when the expectations are too high, people do start to struggle. They do start to lag.
That's interesting to hear. Yeah, I didn't know many people that had that, so that's
Okay.
interesting to hear.
Yeah, maybe it was unique to our university. I don't know, but that was certainly the experience I had. Yeah.
So it's maybe it's good to dream, but not to have high expectations.
Realistic
Yeah.
expectations.
Realistic expectations. Okay, so the realistic expectations should be undergraduate project is. I mean, the first 4 years of doing physics are not so inspiring.
Yeah, I certainly.
But
to
it
me,
gets better as you progress.
I think to me
You
the
can help
realist.
us a little bit more
Yeah.
because you're not doing a PhD.
So you're asking if it gets better?
Better, yeah. As in, you feel that it's closer to what you imagine that you'd be doing, or you're more into what you are doing now than before, more engaged.
I'm definitely more engaged. Bachelor thesis, master thesis versus what I'm doing now. It gets more engaging for sure. It also becomes more like, it becomes more of your own, like, because a bachelor project is usually like, it's like a set out problem, it's probably solved already, like it's not really yours. Sometimes it's even just like a literature review.
Yeah.
And then for me at least, that can be the case for your master's thesis as well, but for me I did some original research, and then it really becomes like, it's your sort of responsibility and your contribution, and that's, at least for me, that makes me really passionate about it. And I guess I feel the same way now. Like, we're doing stuff, and it's like it's an open problem. Like, it's like you're really invested in solving it.
Yeah.
It's really like your problem. Like, you're really passionate about it.
Cool. What are your thoughts on the way physics is marketing in outreach and in material that's made to popularize it? That is, we don't constrain ourselves to just one media. It's sci-fi movies, documentaries, books, everything. So what opinion you have on the way that it's being portrayed to people? Because I mean, at least that's what I think. This is the thing that brings most people in.
It did
Your
with
case,
me,
yeah.
It did with me, yeah.
Your case also.
Yeah.
What the bleep.
What the bleep? Yeah, I mean, that's not a good example because it's not
Okay,
pseudoscience, but
rabbit hole into the rabbit hole.
yeah, what the bleep do we know into the rabbit hole? It's very mystical, pseudoscientific, but still, it did something to it. Like, I think it's similar to must be similar to what you feel with gravity. Like, I think that made me feel like a certain way about quantum mechanics. Like, there's something profound about this. There's something fundamental here. I think, at least for me, that is like a really sort of driving thing. Like, you're really looking at sort of the foundation of the world, so to say, and like that
Yeah.
is just super interesting, and that makes you interested in physics.
Yeah.
Yeah, and I think there has been a lot, certainly in kind of like the last 10, 15 years of kind of like science on TV.
Yeah.
You know, I know kind of, certainly in Britain, like we have kind of, all of the names go through my head, but you have like a lot of these little kind of like, every year we have like a week-long series of shows on BBC about the kind of like space, basically. Like, it's all live, and like, they've got their telescopes out, and you know, it's hosted by like a comedian, and Brian Cox did it one year. And we have like Royal Institute lectures that are shown every Christmas.
Yeah.
So I think there's been a lot of like
The
a lot
Royal
of
Society or
good,
okay.
a lot of good marketing, certainly in like the last decade or so.
But even before that, I mean, there were so
Yeah.
many sci-fi movies.
Yeah.
Maybe it's the sci-fi movies that brought. I mean, Star Trek. A lot of our professors, I think, at least in my experience, they talk about Star Trek a lot, and they're fans.
We had the number 42 return a
Oh,
lot from Hitchhiker's Guide.
Oh, okay.
I don't know if sci-fi movies really do it for me.
Yeah.
Yeah.
Yeah, I would agree. I'm not too.
Yeah, I never kind of. Yeah, I kind of never found. I never really associated sci-fi
Yeah.
with science.
Yeah.
Exactly.
Yeah.
Yeah.
Oh,
Yeah.
really?
Yeah.
Very
I
interesting.
find that,
Yeah.
actually.
Like, yeah,
now
it's-
I think about it.
Abstract, you know, you're like, yeah, it has its place, but okay, this is not.
Yeah.
Yeah.
So you found it appealing, but not because it contained science necessarily.
Yeah, like I enjoyed sci-fi because, like, I mean, I was a massive nerd as a kid.
Yeah.
Yeah.
Of course. But I don't know. I guess I always.
Me too. Just.
But I guess there's always that like knowledge in the back of your head that actually this is all crap, and actually this isn't how anything works.
Yeah, but did you really have that feeling that this is all crap, and or did you want to believe a little bit of it?
I don't know actually. I think
I did. I for sure did.
Yeah, that's interesting actually, because to me, like when I think of physics marketing, I think of the kind of like the reality shows. Reality is a bit of a bad word, but like,
actually, that's a
the kind
better.
of like
That's
these
Documentaries.
documentaries,
Documentaries,
exactly,
yes.
and there have been loads
Yeah.
like that I can kind of think of.
I think there's definitely a place for all of them. I think there's a place for documentaries, and they cause intrigue and they cause this interest in students or in young people as well to get into physics and astronomy and cosmology.
Yeah, definitely.
So I thought that that's what physics was going to be like, but a lot of the times it isn't what your classroom is going to be like, or how even the explanations are going to be like. For example, a class in QFT was very different from when I looked up QFT on YouTube, and just reaching the conclusion that you're treating the field like a bunch of oscillators. That just was never said. Whereas now I can picture it here, and it's different. Like when they do documentaries, they sort of take a step back from the maths and the ruling reality of things and try to give set up a pretty picture. It's definitely, it has its place, but it's also not the reality of a lot of the science.
Yeah.
I think it's interesting you mentioned quantum field theory actually, because quantum theory, QFT is one of these things that it is a bit hip. Like I think a lot of people have heard of QFT.
Sounds
certainly,
cool.
yeah, sounds cool. Certainly for me actually, I always associated quantum field theory with particle physics, and, because obviously it plays a huge role, and particle physics is also kind of hip in pop culture, like every pop sci book is in some way related to particle physics or cosmology, right? But obviously that was never really my interest. And I think because of this, it's actually one of the reasons I never took quantum field theory earlier last semester. And it was about 2 days ago that I found out that actually quantum field theory is used a lot in condensed matter as well.
Yeah.
And so I'm now having to learn
Yeah.
quantum field theory out of textbook, because when quantum field theory is marketed to us, the way quantum field theory is portrayed in pop culture is as this particle physics thing.
That makes
So I think yeah, so I think there's also a, kind of like a double-edged sword there of actually the way these things are marketed can affect people who are actually studying physics in slightly kind of unique ways.
So maybe note to self, if you want to make a career choice, don't base that career choice on documentaries.
Or series. I know a lecturer in undergrad, he taught us astronomy. I think went on to do some mathematical physics stuff. But he just kept quoting the Big Bang Theory. He's a Scottish man as well. Just it was beautiful to see. He just kept quoting Sheldon just the whole time. Yeah, he loved the show.
That's interesting actually, because I know a lot of my kind of like friends from physics hate the Big Bang Theory with a passion.
Okay.
I think a lot of them find it. I think a lot of people find it like quite or demeaning almost. You know, like like they're taking these stereotypes to the kind of next level.
Yeah.
But I guess I'd be interested now actually. Do you guys think something like the Big Bang Theory is helpful or harmful?
It's interesting because I've watched all of it multiple times as well. Like it's good for a laugh, but I do understand that there are some issues. So in the preliminary seasons, there's a huge divide in the fact that there are no women in the physics. There's one, but she's depicted as the bad guy almost.
Yes.
So it is, and then it's more. They always try to show how theorists are, above experimental sense, and that's So there's an air of this. What's the word?
Arrogance.
Yes, definitely. And I think that is. I don't know whether that is art reflecting reality, because there is an air of arrogance amongst theorists for sure. There's huge. I've felt that. I've seen it.
Gotcha.
There's a divide. There's this, looked down upon. I've heard students say things. I've heard lecturers say things.
Can you actually expand on that? Give some examples.
Yes. So a student, I don't know how he's good. The book you were talking about, I was going to say, can you tell me what it is so I can read it for my dissertation? The infinity one.
Oh, I can look it up. Yeah, I don't remember the exact title. It was something like
1, 2, 3 infinity.
You said a brief history.
Brief history of
infinity, something like that.
I feel like there's a lot of a brief history of
Probably
going on within physics.
Yeah, there's another book that popped into my head by Bill Bryson. A brief history of nearly everything.
Yes.
That's a brilliant book as well. Yeah.
Is it like a brochure or
it's like this
long?
big.
Oh dear.
It's like one of those
Encyclopedia situations.
No, it's more like he's a comedian, isn't he?
Yeah,
he likes to light-hearted.
Yeah, very
so it's kind of like a bunch of I don't know if it's little stories or little kind of facts, isn't
I
it?
think so. He goes through several pieces of history of science in general.
Okay.
I think, and so I read that very long ago.
Never heard of it.
Yeah, it's been recommended to me.
Anyway,
So Saba, you were talking about your example?
Yes, so I think we were in labs just trying to do solve one of the problem solving sheets, and this was last term and we're not breaking any lockdown rules. It's fine. So a student mentioned how they might want to be doing either a project in climate physics or not taking QFT or not taking gauge theories, and person A said, well, it's a bit of a waste if you're going to come to the University of Edinburgh and not do particle physics or not do QFT because of the whole Peter Higgs and the whole thing. And I remember a friend of mine turned around and was like, there could be worse things. I feel like that's probably end of the world, And there's just little things like this. There's an air of arrogance amongst lecturers. It's always that. Asking, there are stupid questions. There's no, there isn't an idea of there are no stupid questions. There definitely are in their lectures, or they're trivial, or if you don't know, then that is on you rather than on the explanation.
Never thought about that.
There's also, and the difference is huge. I did some work with, I did a lot more coding, but I did some work with experimental side of things in my undergrad, and just how lighthearted everything is, how relaxed everything is. They speak about physics and they're like, yeah, it's part of the job, it's cool, it's fine, but there isn't this like almost this undying love for, which there is, but not your entire personality or your life has to be surrounded by this. And then you expect that kind of commitment from everybody in the room, and it's just that air of arrogance and not being able to relate to lecturers.
Yeah, and actually, it makes me think. You mentioned about the climate project that's going on. I don't know if it was the supervisor who was prompting that, or one of the other supervisors who was in the soft matter. I do remember one of them very specifically. He was talking about how he was an experimentalist offering a theory project. And I remember, because obviously we had those kind of presentations by the supervisors where they just kind of did their things. And I remember he introduced his talk in a way that almost felt like he had to justify his existence being there, you know. He felt kind of, I can't even remember exactly what he said, but I just got that air from him that he felt like he was intruding on the theorist's space. So yeah, I think it can kind of like, even if it's, you know, not kind of, you know, because I don't believe any theorist out there is maliciously being kind of arrogant or anything like that, but I do think it subtly has these kind of effects on people. And can like make people think, not make you feel like they don't quite belong, you know, even though theorists and experimentalists, they have to work together, the whole fundamental kind of physics is about making theory and experiment work together. And it's kind of sad. But
that is interesting. Like because I definitely recognize sort of the arrogance, but it's more like just like jokey, like in a theoretical. If a lecturer is like a theoretical physicist, he might make like a joke, a lighthearted joke. But at my university there was not. I didn't notice this sort of arrogance in the theoretical group versus the experimental, and they are quite closely related in our university. So maybe that also like makes a difference, like how closely the departments are working together.
I have noticed a difference in fields as well. Like I've noticed kind of like certainly my condensed matter lecturers have all been a lot more approachable and a lot more kind of like they feel a lot less kind of intimidating. They all feel a lot more kind of I guess approachable.
Interesting.
So I don't know whether there's a kind of
now I'm thinking, are we having these sort of views of theoretical versus experimental, maybe because by chance we've had like a grumpy theoretical lecturer?
I think, I don't know, so I don't know whether this is a trend. I don't, there are some lovely, approachable theorists out there as well, and I have experienced that, and that's great. But I don't know if it's just what we've encountered, and I will agree with you as well. I dropped gauge theories for biological physics and statistical physics.
Yes.
And I cannot even begin to say how much I've enjoyed biological physics.
Yeah.
Because the way it was taught was, and there's 60 people on that course too, so it's a big course. But the way it was handled, the way it was, everything was done sort of in a very relaxed way. There's a lot of, the workshops were designed with 1 hour in mind, and the questions sort of reflecting that. There was no I didn't feel any air of judgment. I had to give a presentation as well. It was very different from a research for theoretical physics. So it was very different. I felt a lot more relaxed. I don't know what it is. I think it's just.
Is it maybe something to do with? So it feels to me that you're saying theoretical physicists and mathematicians maybe might be less empathetic towards
Def-
students.
I would say that. I would say.
Yeah.
Yeah.
I mean, that's a big statement,
Yeah.
you know, because we're also putting this
Yeah.
label onto a huge group of people.
Mhm.
Yeah.
Mhm.
Oh,
It's not,
absolutely.
it's not okay, but
Yeah. Like I said.
maybe there's some truth to that.
Yeah.
But the reason I asked that question just now was because I had sort of like not a great, unapproachable professor for my analysis. My first ever real analysis course in my undergrad, and that was when I was switching from physics to math. So that was sort of my first exposure to that.
Yeah.
And then later on, I had a sort of similarly intense, but not in a good way, lecturer for my partial differential equations course. And I'm thinking now, does that explain my aversion for those two subjects?
I also wonder if, to an extent, the kind of the popularity of theories of physics plays a bit of a role, and if maybe the kind of people who are more likely to become successful in theoretical physics are the kind of people who maybe are a bit less caring,
Yes.
But again, like as Christian says, maybe this is just the lectures we've had, and yeah, I'm not 100% sure because it feels a bit weird to kind of say that actually theorists are arrogant, especially when we ourselves are theorists.
Well, I can definitely say I've made these sort of jokes with my friends, like they're, or like there's like a banter going on.
Yeah, definitely, yeah. I would say,
Maybe it's even a bit of a self-fulfilling prophecy. Maybe
Yeah.
people have this kind of idea
Yeah.
of experimenters and theorists, and so they spot
Mm.
the people who reinforce that, and
Yeah.
maybe they justly ignore the people who don't.
And maybe that's the way you get far in the field, or you see the theory side of it is more difficult. Then once you overcome it, you sort of don't have that empathy. Well, if I could do it, if I worked hard and did this, then anybody else can, and I shouldn't be that empathetic. I don't know if that's the case. I don't know.
Might play a role.
Exactly. I mean, it could be different cases, but a lot of the times we must also recognize that there are different things at play for us to be successful. Not just me. I know there's a lot more going on. So yeah, that's that.
Regarding university decisions, so I get that in your first year of university you weren't really clear on what you want to do, so it's fair to say that,
Yeah.
I think because I had to make this step from engineering physics to university, I did sort of already know I want to do theoretical physics. That was the main reason why I made that jump.
Yeah.
And I suppose that's when sort of the idea also started to form, like research is pretty cool, or I didn't know back then what research really was. Which is also, by the way, what I wanted to mention, like pop culture does not show you what research is. Which it does, I don't think it has to, but that is maybe also an important point of what you were trying to say, of the disappointment when you get to your bachelor thesis and it's not quite what you thought it would be. I think research is like a whole different sort of beast that you just have to experience. To really get to know.
Might it be that research is not really easy to portray on any...
For sure.
It
It would also be very boring probably to portray. Because
it's very much grinding through a problem, sitting at a table and...
It's hard work.
Can you romanticize that? I don't know.
You
Maybe
can
just make a montage of one person
No, you can definitely romanticize
today,
this.
tomorrow,
there's
doing
like
the same thing, right?
myths of these great
Yeah,
mathematicians and
definitely.
physicists.
But then again, romanticising it is inherently causing the
Expectations and disillusionment.
research isn't romantic.
And at the same time, it's inspired, I find.
Yeah,
personally.
absolutely, yeah. No, I think the sheer fact that documentaries and kind of fiction and all that kind of, they have to make you enjoy.
Yeah.
And research is enjoyable, but watching somebody sit there for 6 months
Yeah,
would make a pretty crap film.
yeah.
And I think that's the thing, it's like research is a lot more time intensive than they portray, and I think that makes it difficult to portray accurately.
What would you say about, and this is maybe a more of a philosophical question in general, that all these documentaries present these problems and the solution as it literally took no time to come from one to the other. And exactly that thing that is not portrayed, that is the most relevant thing to what you actually do.
Yeah.
So it's funny that you go into physics thinking that you're gonna enjoy these solutions and big moments, bright lights, whereas exactly the thing that's not portrayed, it's like the devil is in the details. Exactly what's not shown, that's what you're gonna get.
And I guess it's like...
So it's misleading, it's definitely misleading. If you want a career in research, documentaries don't really cut it. Documentaries, sci-fi books, anything really.
Yeah, I think it is worth pointing out, like, I know certainly I've kind of shit-talked physics a lot at this table, but I still love it, I wouldn't be doing anything different. Like, I gave up an incredibly high-paying job to come back to study physics. But I think the reasons I love it have nothing to do with the reasons I chose to study it. I think
can you unpack that?
Yeah, I guess but I guess that's kind of what I've been talking about in saying that like physics is not portrayed very well. So I chose physics I guess I chose physics partly because I was good at it, partly because I liked doing what I was doing back in like A-levels and stuff, but also, as I said earlier, that you do have this kind of idea that you're going to be the next Einstein. And obviously you're not, but you still find something to love in it, I think especially if you enjoy what you're studying, it then doesn't matter what comes out of it, because you can enjoy the process itself.
Question related to that. Did you find physics, what is most appealing about theoretical physics, is it different now than it was before you joined university?
I would actually. Personally at least, I actually studied theoretical physics, not for the theory side, but for the computational side.
Right.
And that's because of what I did in my job. In my job I was doing kind of mathematical programming, so I was doing numerical programming, and I wanted to do that, but in physics. And that's why I went to, and back my undergrad was just a plain old physics degree. I did an experimental project. And so, yeah, certainly for me, the reasons I kind of went into physics and the reasons I went into theoretical physics, very different. And what
Right.
Yeah.
So before it was about, you liked physics in general, you liked the topics that are being discussed, but now it's more towards I want to work.
What I want to be doing.
It's
absolutely.
It's about maybe simulations.
And kind of like that.
So it evolved. It definitely evolved.
Absolutely, yeah.
What about you guys?
I knew once I knew that I was going to do physics that I wanted to be in academia. And that was sort of whatever glamorized image that was in my head was very linear. Do my undergrad, get a master's, get a PhD. And I think a lot of great, because you have sort of like, you are in that halfway, almost, there. But I feel like it's not going to be a linear process now. Doing an undergrad is great, but that's literally just step one almost in academia. I remember there was an alumni came in and they had a chat with the current students, and I remember them saying, look, a physics degree is difficult, make sure you take a break. And I remember counting on that, and I said, okay, I will take a break in my at the end of the year, my third year. And I will take a break before I do a master's, but circumstances were such that was not possible. The whole world was not taking a break. And so then we also have to understand that there's elements of like burnout, there's elements of dealing with situations that you didn't think that you were going to deal with. So I know now that this isn't going to be a linear process. It may affect my education in the masters. As a result, that could you know, it might be a weird process to get into a PhD, or there will be a break. So things do change, and we should be okay with getting over them. And there's a period of heartbreak that you have to get over as well, because that's not possible now, or you're just suspended in this state of I need to survive this before that, and then things change, and we need to sort of be okay with that. Consider these things that might happen, and it's not always, we don't have to go from undergrad masters thingy to be in academia. We can take breaks, and that's completely fine, and that's also a way to do it. And it should also be a valid way and a way to be, you know, a good way to consider doing things.
Can you actually repeat who told you that you should take a break before the masters? Or
I don't know the person's name, but it was an alumni from Swansea Uni, and they were giving a presentation about what they were doing now.
Right, yeah.
So they said, look, I did the same degree, and it's a physics degree is a difficult degree. So before you do anything, make sure you take a break. And I've since starting this year, every day I think that voice just echoes in my head every single day.
Interesting.
Yeah.
So Nesta, did it evolve for you?
It definitely did. To this as well. Two things you said. Like first, you were talking about how you had sort of an idea of quantum field theory in your head, and then when you actually started doing it, it turned out to be very different from what you sort of imagined. I've had that with a lot of my courses. I think, like, especially you sort of start to realize that it's not as glamorous. It's very like sort of once you actually have to do sort of the details, the technical details, it kind of takes like the flair out of it. So that was one thing that definitely you can learn to appreciate if you like that sort of thing. But that for me, definitely with certain courses, that was definitely sort of a wake up call. And then with the linear stuff, so talking about university, obviously I changed from physics to math, so that was already a bit weird. So bachelor's at uni are 3 years in the Netherlands, and the master's is 2 years. So I had to do 1 extra year for my bachelor to be able to switch over to math. So that took me 1 year extra. So that was already a bit weird. So all my physics friends were like already doing their masters, and I was like still in my bachelor basically. And then in my second year of my master's, I sort of had a burnout as well, where I basically I started a master's project with this awesome professor, but I didn't sort of dig it, so we stopped, and I sort of burned out, so didn't do much for the rest of the year. And that already made me question, like, do I want to continue doing this? Like, I was applying for PhDs, and I was being rejected all the time, so it was like, do I really want to do a PhD? Like, is this really what's going to be good for me? And then in my third year, so my master was 3 years as opposed to the usual 2 years. In my third year, I started another project with a different professor, and after a few months of being stuck, that went super well. And then I also got a PhD, so then I was like, so this is what research can be like. It can be fun if you're making progress. And I got a PhD, so I was like, okay, maybe this is, after all, something I can do. So it was definitely a roller coaster. Like, I didn't know, like, especially around like the second and third year mark of my master's was very sort of tumultuous. Like, where do I want to go with this? Do I still want to stay in academia or not?
Would you say that your decision was circumstantial as well? So if you hadn't gotten an offer, or that hadn't gone well, things might have been different.
Yes,
and that's okay, right? That's it's fine. We need to be able to be okay.
And of course, you can choose a different path in life and change back. It wasn't difficult for me to come back after 4 years away.
But maybe we should keep in mind that you're coming back to a master's. You're not.
That's true.
Not doing a PhD. I mean, I think there is a bigger gap. It's the same for me. After 2 years of break, I come back, and it's still very hard to get back into it. I mean, right now, it's already.
I think that's it. Like,
and for you, even harder.
It's tough. yeah, but I think kind of it wasn't difficult to get back onto that path.
Mm.
You know, yes, obviously, like I'm working very hard this year and
Mhm.
I'm struggling a lot this year.
Yeah.
But you know, I think when I left university, I had this idea in my head that was it. I couldn't come back.
Yeah.
You know,
Mhm. Ah, okay.
whether I regretted it or not,
Mm.
this was my life now.
Mhm.
And it took me a long while to realise that actually no, that's not true.
Mhm.
You don't have to stick on that
Yeah.
linear path. You can wander around it.
Was there some person that made you come back, or was it I'm not really passionate about what I'm doing now and I want to?
It was more that kind of that. I think
So
I
more
started-
personal drive.
Yeah,
and,
there was kind of like a kind of I think weirdly the big thing was I started reading Physics World again, and about kind of like after about two or 3 years of being out of physics, I still had my subscription, and I kind of picked it up, and then a couple of months later I was like, you know what? But,
Yeah, very interesting.
Yeah, that's a cool.
Mhm. For me, it was after 3 years of university, I wanted to take a break, but for other reasons. Mainly it's because I got burnt out.
Yeah.
I was working part-time while studying, so it was
Yeah.
pretty difficult to get through everything. I mean, I could have done the 4th year, but I always felt that my results were not as good because I was working
Yeah.
part-time. And I said, okay, I'm gonna just quit physics for a while, make some money, and then come back into it with full strength.
Yeah.
Seems that even though I have all the time in the world right now, it's not made it easier.
I
No.
mean, yeah, the situation isn't ideal for studying.
Yeah, even I don't know, maybe it's even the masters that's quite a step up.
Yeah.
Yeah. So maybe one thing that's worth mentioning, the first year of university is quite okay in terms of the jump that you need to take from high school.
Yeah.
It's doable for most people.
Yeah.
Certainly, yeah. I think for me it was a lot of the same topics we'd covered at kind of
Yeah,
A-levels,
pretty much.
with
And-
maybe a few extra bits on top. Yeah.
So first year really easy compared to what's coming next.
Yeah.
Then second year hits, it's a big wall there.
Yeah.
And then second and third year are quite similar, at least that was in my case.
Yeah.
But now the masters, I was expecting it to be the same as third year.
Yeah, same. Yeah.
That's not what happened.
No.
That's not what happened. Huge step up
Yeah,
again.
I think that also has an effect when you are at a different university. So you have to deal with a change of the way things are done, different lecturers, different curriculum perhaps. A lot of these things. I know for the university that we're in, a lot of the program and the modules are catered and tailored towards MPhys students. So students who are going on to an extra year, who have done their undergrad in the same uni. Examples of this would be having, for example, cosmology in the second term, but advanced cosmology in the first term. This is to cater to MPhys students.
Yeah.
So that's definitely worth considering, and I believe it is a huge step up, and I agree with you entirely there. It's very, very different, very difficult, and a lot of the times I didn't realize the things that I would do differently. I would have just as a word of caution, like I would have done a lot more research into the modules before even coming in, knowing where my knowledge gaps were and filling them up, because no one, if you have great support, that's great, but a lot of the times you will not be told in your masters that you do not have the knowledge for this course or the prerequisites for this course, but you want to take it, and they will not discourage you a lot of the times. They throw you in the deep end, and you have to survive.
Yeah, there's certainly one course that comes to mind there. Which,
a lot of courses come to mind.
no, certainly.
One question that I wanted to ask, just give me a moment. So talking about it came before in the discussion, but I didn't raise the question. Do you feel that there is enough guidance given while you're doing your degree so that you know that you're making the right decision? Or because as you said, you made the choice not to study QFT because you had a feeling from documentaries and all that time ago, sci-fi books and popular science books and so on, that it's not the thing for you. Actually, it is now.
Yeah.
No, yeah.
Somebody should be there to correct your intuitions that are sometimes just inherited from this popular science stuff.
Yeah.
So do you feel that you're receiving this support? Is it maybe more than through your colleagues and the people that that are older and they kind of guide you, don't take this course, take the other one, or where is the most guidance coming from, or is there enough even?
I don't know if I can really comment on this with regards to this university. I can quickly
supervisor.
I can quickly say with my master, there's when you're just starting, you're supposed to make an appointment with the head of the program, and you're supposed to prepare a little package of courses, and they'll discuss your interests a little bit, and this is a good course to take or maybe not.
How much time? How much time is that?
How much time would
that meeting? How much time does it take?
Not very long.
Half an hour?
Not even.
So half an hour to dictate what you're gonna do for your
I mean,
for 1 year.
It's there's only so much you can choose from, so it's not like they cannot do that much more than just having that meeting, right?
No, but equally, so I guess in personal experience, this kind of is the job of your personal tutor, at least in Britain.
So we don't have that. And can I, before you continue, I was not really satisfied with the courses or with some of the courses I did choose. So it, maybe to your point, it did not end up being the courses that I wanted to do necessarily, and later ended up regretting not doing some other courses instead. But also that maybe because of my shifting interests and
but then I feel so when I spoke to my personal tutor, he asked me what was I interested in and what I want to do in the future. And then we had that list of courses prepared, and he looked at the courses, and the courses happened to match up with what I said, and that was it. He offered not once did he say, oh, this is a course that might interest you. He didn't say anything about, oh, maybe these courses won't interest you. It just felt like he was ticking the boxes, And I think that differs a lot from my undergraduate personal tutor, who I felt, and maybe it was because she had 3 years or 4 years to get to know me, but she actually had an input into the courses I took. She actually discouraged me from a couple and encouraged me to others. And so I think it very much depends. Depends on. For me, it depends on what my personal tutor's like.
So you've done in Netherlands, so you only have contact with the head of department that's giving you this.
So it also differs depending on the undergrad or masters. But for masters, so we don't really have a personal tutor like you guys have it in the
undergraduate or masters.
In neither. But for masters, it's a professor who happens to be the director of the program, so they design, or they're in charge of designing what courses are there. And so the master I did is divided into 2 or 3 specializations. So if you do that one, so mine was mathematical physics, so you have a certain number of courses that you have to do, and then the rest you can sort of fill in the gaps yourself. And then you come to them and you say I'm interested in this and this, and they might be this is a good course for you. Or happens is your interest, at least this happened for me, my interest shifted, or it's not that my interests shifted that much, but I realized I do actually want to focus more on these other sorts of courses than the ones that I thought I needed. And then they try to tailor it to the master thesis you're going to do, but also that you don't know what you're going to do for your master thesis when you just start.
So most of the credit for your choices should go to you.
That's
As
what
in-
ended up.
Yeah. As in you kind of dictate your
Yeah.
choices. It's not he has a conversation with you from square one and
No.
he talks you through, okay, what did you enjoy in your undergraduate and did you have your best results, and he kind of makes a recommendation on, okay, these courses might be for you and you can do this and that. I mean, that's what I envision as a tutor, right?
Yeah, I suppose the existence of these specialization tracks sort of serves that purpose already.
So you should be aware in advance that they exist, and you should be.
Well, I think when you're entering a master, like, so the two main specializations were either mathematical physics and algebra and topology. So you kind of like know which one like sort of sounds the best to you,
Yeah.
and then that already gives you sort of a template for the courses that you.
Right. And there's not so much choice, so in the end.
There is a lot of choice, but there is like a framework that you can build around.
Mm-hmm. Definitely.
So yeah, this might be completely different too. What is
Yeah. So generally, it's only maybe 1 hour of guidance that you get for your choices. So everything else, you have to know yourself.
Yeah. I've had a similar experience to Sean. I wasn't even asked what my interests were.
Oh, really?
It was,
God.
and we share a personal tutor.
Yeah.
We all three of us
we all
do.
do, yes.
I wonder if that's maybe a bit tough.
I mean, yes, because I know that this personal tutor has about 40 students on their hands, and
That's too much for
right, and so I think it was maybe a 15 to 20 minute session, if that. I'm not too sure. And I don't know if this is a personal issue, but a lot of the courses have, I don't know if this is this university thing or this is just everywhere, but a lot of the times the names of the modules are extravagant and don't reflect what they have what they contain. And yes, you can read description, but those descriptions can be one word descriptions and a list of them. And you don't know. So I didn't know what quantum field theory was. I had no idea. I know it sounded cool. And I was like, okay, I don't know if I read the prerequisites, but I had a chat with the personal tutor and I said, what is quantum field theory? And again, it was like a short description and a very what's the word, cartoonized description of it, thinking that I was able to do this, and no word of warning was given that if you haven't done this before, it's a difficult one. The statistics of this module is that certain percentage of students on this graduate with certain grades, and I've heard this now and it's haunting. And this is a trend that's been happening throughout the years. None of stuff like this was this guidance wasn't there. And when I had a little bit more awareness when I was choosing my modules for the second term, I realized that there was a whole world of things that I couldn't take now because I hadn't had the prerequisites that I could have taken in term one. Variational calculus, I couldn't have, which was a prerequisite for string theory, and I hadn't taken that. And I had to almost pick string theory because there was a 50% coursework. So I thought at least maybe then I'll know how, I'll still learn it. But there was nothing like that was said. It was and I didn't know a lot of what these modules are, and I don't know if that's a personal issue or.
No, I think it rings true to me too. I didn't know what UFD was, and
and a similar thing actually, which I think we've both faced, is there are certain courses where no prerequisite is given because it says the prerequisites will be taught in the course, but because you're trying to teach prerequisites and the actual bulk of the course, unless you've seen the prerequisite before, prerequisites, you actually struggle a lot to pick it up in the first place. And maybe that is the fault of the lecturer, maybe it's not. I know certainly there are some courses where, for example, functional derivatives were introduced in a couple of different courses, and that worked fine. But then functional derivatives are just a small part of, they're quite easy to pick up. Whereas when the prerequisite that's trying to be taught is an entire field of maths,
Yes.
it suddenly becomes a lot more difficult.
Yes.
So yeah, I think that's a similar kind of issue that I've certainly faced.
So is it almost like at the very start of the year, you already need sort of a plan for the whole year,
Yes.
while you don't even know
Yes.
what everything is
exactly.
about.
And obviously we don't know the kind of depth of field. So you didn't know that condensed matter needs quantum field theory or any field theory.
Exactly.
I didn't know that. But and a lot of things in physics are related like this.
Yeah.
So knowing at least maybe what would have helped would have been that there might be some mandatory courses that we need to take that has all of the maths, for example, or some of the theory or some of the tools that you need for a bunch of then routes. Whereas right now it's all electives, bar two. And some universities do have this. So I know Cambridge and Oxford have the mathematical tripos, which is a lot of them are mandatory classes that you take, and they really give you a good, well-rounded education in that sense, and you know there are some things you have to know to be able to do certain things.
I think even maybe like a presentation at the start of the year where they just go over each module,
That would be good.
give a quick 5-minute talk on this is what it covers, this is what you need to know, and this is where it's useful, or something like that. Or maybe there are just too many courses for that to work.
Maybe they should make. I know in Oxford I had a look at the masters before, and they have a certain profile. As in, you can be a theorist or a string theorist, and they have this profile, and then all of the courses are listed. This is what you need to do if you want.
Exactly. That is good.
Something like that would work.
Yeah, so that's sort of what we have.
Yeah. It was gravitational something. I don't know. It was there, so you know what you have to do.
Well, maybe it's just that, because obviously we have this tool that we use to pick our courses.
Yes.
Maybe that tool just needs to be a bit better.
I would agree to that. There's a lot. There's just a lot going on. You miss one, and they all just blend in together at one point. And then there's things like you have to have a certain amount of level 10, level 11. Then you have to have a certain amount
that
of.
was so confusing.
Yes, you have to have a certain. If you're mathematical physics, you have to have 3 mathematical physics modules. It's a lot for a student who has not dealt with that situation before, who's new to the university. Doesn't know what to do, right?
It's only half an hour that you have to blend everything together and boom, that's it.
Decide your future.
So that's tough, and maybe they don't really make us aware that this is the way that it's gonna go. I mean, they say that you can change later, but still, it's only the first 2 weeks that you can change.
Exactly,
really.
and then you miss 4 lectures already, which is so difficult to catch up on. And it's almost this thing of when you were in undergrad, or if you were in high school, or even in undergrad, if you didn't know something, it was easy that you pick up this giant book that's called Mathematics for Physicists and Scientists, and you open one chapter and you look at it, and you say, okay, this is cool, I can do this. But when it comes to masters, it's so niche, it's so advanced that you can't just teach yourself these things. A, because the textbook just doesn't resonate with you, or B, there's no, if you're a visual learner, if you like things actually done out, worked out, then you don't have that kind of content online. If you do, it's a lecture from a university that's an hour or 2 hours long.
Yeah, that's already double the work.
And of course, textbooks are notorious for being terse and leading a lot to the reader anyway. Which is what lectures are supposed to be, really. They're supposed to fill in those gaps.
So I feel that we are complaining a bit,
Yes,
but I think
that
it's
is
for
fair.
a reason. It's for a reason. Definitely, this is one of the points that people should consider a little bit more. That your future is definitely decided by you mostly, and be aware what your biases are and the wrong ideas that you kind of pick up with the years.
And take responsibility, and take time for doing a lot of research. Don't just think that I'm going to start when I start. And that's what I did. I was like, let me take this vacation time, which wasn't even a vacation, but and then I'll figure it out once uni starts. Don't do that. I would recommend.
No. Yeah, lots of little as well. I'd say, you know, don't wait till the end. Just do little bits. Lead the way through.
So related to this, now we are at the point that, at least you know, us three, we're looking for a PhD, and this is very related to the guidance that we receive, right? So for me, you know, at least you know, before university, I knew that gravity was the thing. So for me, it was kind of easy because you know I know that gravity is the thing that I want. I don't know why. Still, I don't know why, but you know that's what I want to do. So there you go. So at least I have some sort of idea of what I want to do. But then again, it's gravity. You can study it in 10 different ways. You told me about your Professor Roller, was it? That was doing another way to study quantum gravity. Roll it.
LOL, actually. LOL.
LOL. Okay, sorry.
Yeah,
Roll.
she is one of the co-founders of causal dynamical triangulations.
Yeah. So another approach to quantum gravity.
As one does.
So you know, I could take that route, right? Or I could take many other routes, that string theory, and then quantum gravity, and you can, you know, go to this department or the other. I mean, most of the time, the search for a PhD is very, it's very opaque for a person that's outside. And even for us, even though we went through almost 4 years or 5 years of higher education, you know, undergraduate and masters, we still have no idea what these research topics entail. And this is the thing that we're gonna set up for ourselves for the rest of our career, academic careers, if we want to have one. So it seems that most of the time it's a very opaque process. So how do you feel about that in general? So for me, I had a guiding light. Let's say it was easier, but
I think it's definitely important. Well, you should go for what intrigues you, and I know I do want to go into either particle cosmology, and interference of these two, just anything. In that sense would be great, but I am also open to other opportunities if they present themselves, or if I go looking and you know I find interesting. But what I haven't done this personally, but I have heard from other students applying that, or PhD students in general, to try to find the department and then the supervisor that you're going to be working with, correspond with them, try to get an impromptu sort of Zoom session, and nowadays to have a little chat about these things. If you can sort of contact the department and do this through LinkedIn, that's also a way to do it. But definitely try to do as much research as you possibly could before even getting there.
One question before that, Sean. So you said that you wanted something related to particles and cosmology. Why?
That's just, I don't know, it's like the bigger questions for me. It's
I think that's a good answer. That's a good enough answer.
I mean, I will also say through the wormhole with Morgan Freeman. I will also just slap that. Morgan Freeman, if you're watching. I love that show.
No, I'd say for me actually, because in a way I was quite similar to you. Like I kind of, from about the kind of like third or fourth year of my undergrad, very interested in condensed matter, and that's kind of like, and again, like both of you, I couldn't say why. There's just something about it, you know. I wonder if a lot of that comes from the courses you like see when you're at your undergrad, but yeah, I knew what I wanted to do, and you know I had the kind of the condensed matter stuff from my undergrad. I got really into algorithm development, my job, and I knew I wanted to do something computational, condensed matter kind of stuff. What I've really struggled with, and is kind of the reason I've not applied to many PhDs this year, is that I just cannot, for the life of me, find good departments. You you know, it's like you've got sites like Find a PhD, but it's really difficult to narrow down kind of like your search terms there. You either end up finding something so narrow, nothing comes up, or it's so broad that you have to scroll through like pages and pages.
Are you looking only at UK? Or have you looked only at UK for a PhD? Or
I'm only looking at UK universities. Like what I ended up doing for a little bit was like just grabbing a list of all UK universities, just going down it.
I think that's a good idea, to be fair.
It is, but it takes a fucking age. It's a tool, it really is. It's difficult to do that. But yeah, I think that's where I would want more advice. You know, I want, because like, and obviously now I'm working with my project supervisor. He has kind of pointed out some decent.
But it's too late in a sense.
But now it's too late. You know, nobody's really. You know, there are some universities that are still kind of accepting applications, but most are kind of at their final stages now. So yeah, I think that's where I really would want to see more advice. Is kind of where do you look if you're interested in this topic?
Yeah,
definitely. So Nesta, for you?
Yeah, I definitely knew the type of subject that I wanted to do for a PhD. Like I suppose like all of us then. So I was looking for those types. So one thing I did was subscribe to a mailing list. That is just a mailing list that announces like seminars and postdoc positions, PhD positions, that sort of stuff on that particular subject. And then very occasionally there will be like an advertisement for a PhD position. And that's how I found the one that I eventually got. But also sites like Find a PhD, there's also a site Math to Jobs or something.
Yeah, there's also, I think, Inspire Hub for higher energy physics.
Okay.
That's
Does
for
that have
jobs.
jobs?
Jobs, that's mainly jobs. And postdocs and all that sort of stuff.
Besides that, I just asked my supervisor and my ex-supervisor, like, if you guys find anything, just shoot me an email, and or if you know anything. So yeah, mostly it was just very specific search terms, like the field that I wanted to go into, PhD, and then just Googling for weeks.
And that's the rest of your 3-4 years.
Yeah, I mean, and then a lot, a lot is like, this is like not really what I want to do, so I'm not going to apply for that. So you kind of have to weigh, like you said, worth it applying for that. Maybe I'm lucky with this, but I can say it tends to be somewhat flexible what the project's going to be. So if you sort of find a supervisor or a project that is roughly what you want to do, I would encourage you to apply for it, because you can. It's supposed to be your project, right? It's supposed to be your research, so you can very likely give a very good twist on what you want to do.
Yeah, I've actually heard that from a couple of people I know. One PhD person was TAing for one of our courses, and she said, don't be too picky, because exactly that you can. And also one of the kind of potential PhD supervisors I talked to, he was talking about how like the PhD that I was talking to him about, he'd had 3 people kind of start it and then adapt it into something slightly different, such that what he actually wanted to get done originally just never ended up getting done, because they all kind of twisted it into something else they liked. So that definitely kind of sounds insensible.
But don't you think that finding a supervisor, it's kind of a lucky circumstance? As in, you find your supervisor somehow that does something that you kind of like, and instead of you know what you're into, gravity in my instance, and then you just start looking and you find departments, but you message people, they don't respond back.
That's why I didn't know I was going to do this specific topic. So what I wanted to do is something with category theory. So I just looked for category theory PhDs, and then you sort of find like this broad variety of projects. and you just apply it to them
Yeah.
if they sound sufficiently interesting to you. And then,
Yeah.
And then eventually, if you start, you will also sort of develop an interest for it.
Yeah. True. No, it's very interesting because you start with so little, and it's all in your head.
Yeah.
Then.
Or well, nothing's in your head initially.
Yeah, initially it's just the
Yeah.
expectations
Yeah.
and hopes.
Yeah.
Hopes.
Yeah, a lot of
Hopes and dreams.
Hopes and dreams, and then
Yeah.
you start doing it, and
And a lot of crushing of those hopes.
Yes, yeah.
yeah, so quite difficult. It's definitely one of, I think, the most difficult decisions that we have to take, because it's a lot of our life will.
Yeah,
Go into this.
I definitely don't envy you guys. Like applying for PhDs was very stressful for me.
Yeah. Cool. So going on to physics lifestyle.
Okay.
So
Lifestyle.
this is gonna be
lifestyle.
this is gonna be the last section of the podcast.
Mm.
First question: how difficult is it to find a balance between work and life if you're studying physics, theoretical physics?
Simple.
Yeah.
No, I kid. It's hard. It is. I think.
Have you managed to find it?
I think I have now, and I do wonder actually how much COVID itself has affected this. But yeah, I do think the first semester especially I was really struggling to, like, I was either doing too much and getting kind of exhausted and not being able to do things, or I was doing not enough. And I think now I'm kind of, especially now that we're running up to kind of exams, I'm kind of, I've been able to schedule a bit better,
And there's a sense of urgency that
there's also
you need to get stuff
Yeah.
done.
Yeah.
But I think the thing I was finding really difficult actually, because about 4 or 5 weeks ago, actually I just stopped going to lectures because I find it so difficult to fit in work around the lectures. It's like
Yes.
a lecture finishes, you've got an hour to get something done. You want to have a break. You want to maybe get a bit of food. That ends up being only half an hour to get something done. You also want a break before the next one starts. What about kind of you guys? You also?
I really struggled first term, just with any there was no balance, there was nothing.
So
There was
that's
just
talking
chaos.
about the masters, which
Yes.
the masters also has COVID on top of it.
Yes,
But
yes.
we also, we can talk about the balance as we found it in our undergraduate as well. Just want to point this out.
Okay.
That's true. Yeah.
I think in an undergraduate, it was, I think the structure of going into uni and then just extending that, regardless of how many lectures I had that day, spend a 9 to 5 or 9 to 4 or whenever your first lecture is to 5 or whatever you could. Even, later some days if you have a deadline then you can extend that. But putting in the hours every day was kind of nice, and you have this rhythm that you can follow, and then make sure. I think the one thing that I can say about a successful undergraduate life would be that is, if you are in the British, sort of gives you deadlines beforehand. What I would do, and a friend of mine, we would do this, if you can find a study buddy that is brilliant, and then get a calendar out, a 3-month calendar or a term calendar even, put down your deadlines so you can see them, you can see how many weeks you have, you get this mental image then in your head where you can touch and feel these things. So then you can plan when you're going to work for these deadlines, and then you obviously know your lectures, then nothing almost jumps at you, and then you can plan sort of if you want to have a day off, if there are birthdays, if there are fun times, if there are different things, you can sort of plan them in, and it takes, you don't have to do it on the first day of term, you can sort of get in the rhythm and then start doing this once the dates are out. But I found that this uni I wasn't able to do this with because a lot of the dates kept changing. So I wasn't able to do that, and there's a lot more work that required to be done on a daily basis that I didn't understand. I wasn't able to keep up. So first term was utter chaos.
So same feeling for all of us then.
Yes, just utter chaos. And I think that second term has been better in the sense that I'm moving, because we're lucky enough to have a study room,
Mhm.
going there, spending the hours there. I'm obviously not working every hour that I'm there,
Mhm.
and there's a social element to it. There are breaks, there's movement, there's there's a difference in that, but that's been good. I've been doing the 9 to 5
Mhm.
kind of relative. I mean,
Yeah.
just hours in. But yeah, that's good. And I think we have to let go of the idea of this perfection in terms of what
Yeah.
productivity looks like.
Mhm.
It doesn't always look like you waking up at 5 a.m.,
No.
going for a run, coming back, reading 10 books, doing a yoga
that's
session with like
very
loads of
American
people.
way to.
But it doesn't look like that, and then you can have things like deadlines that you will work towards the 2 days leading up to it. You really work hard and you put in a lot of hours.
Mhm.
And after the deadline, you have to take a break. You're not going to be productive
Yeah.
that day or the next day.
Mhm.
So knowing these things as well and working around it, and not trying to have this like glamorized version of productivity. I think you have to come back to reality in a sense.
Yeah.
Actually, I wanted to.
Work.
Yeah. No, I wanted to actually touch on, you said about undergrad as well.
Mhm.
Do you two in particular, do you feel that the Masters has been a lot busier than your final year of undergrad was? Because I certainly have. I think I'm doing, about 20 hours of lectures a week, roughly.
Wow.
20 hours. How many subjects are you?
It would be 5.
Yes.
But, sorry, 10 hours of lectures.
10 hours of lectures,
10 hours
but
of
then
lectures. But
tutorials on top of that.
Tutorials
right?
on that makes it 20 hours, yeah.
Yeah.
Okay,
Yeah.
And I feel like, and obviously 20 hours, that's 4 hours a day of
Yes.
stuff that you're supposed to attend.
Yes, not even just stuff you're supposed to do by yourself, right?
Yeah. Yeah, so and we've always talked about how it's difficult to fit work between these
Yes,
things.
yes.
Whereas, and again, it was about 4 or 5 years ago now, so maybe my memory is just hazy,
Mhm.
but I don't remember feeling this pushed for time back in my undergrad.
Definitely.
I feel like back then I had a lot more time to actually do my own work. I was wondering, do you two
Yeah,
feel the same?
definitely.
Yeah.
So that's
Okay.
one of the reasons that I'm not even attending any lectures or workshops.
Yeah.
I just do everything on my own. That's it.
So
Yeah.
that's another. I think that's a brave. I think that you require this certain level of something to be able to do that. For me, one of the biggest fears is if I don't do this, then I won't get anywhere. So I think there's a level of confidence required to do that.
Yeah,
And I'm
yeah,
doing
yeah.
that at the moment with a couple of modules that do put up solutions,
Mhm.
but the 2 modules that don't, I am.
Really?
Yeah.
Oh
Yeah.
god,
So-
no.
Or
All
they-
of my modules without solutions, fortunately.
They do, but they are very difficult to understand, or they're only hints.
God, yeah. Oh god, yeah.
Physics, I will say this is. It's
Oh,
very intense.
nasty,
It's very, very intense. The lecture is great, but also the module itself is just very
Yeah.
Mhm, mhm.
intense.
Okay.
Yeah. So definitely it gets harder in the
Yeah.
masters, but once you're doing your PhD, it's more up to you how many.
It's a blessing. You
Yeah.
can do work whenever you want.
Yeah.
PhD, it's a blessing.
In that regard. Well, yes, I am very fortunate to be doing this. So
Yeah, if you have the right
every
supervisor
step.
and you're doing what you like.
So that
Yeah.
I am just very lucky. But
Mm.
it's definitely, you get busier and busier up until the master. And for me, even with my master thesis, that's the only thing I had to do.
Mm.
I just had complete control
Yeah.
over
Mhm.
when or what I was doing, basically.
Mm-hmm.
Which I personally really like. I think it may not be for everyone.
Mm-hmm.
Some people might need this sort of enforced structure or routine to their day.
Yeah.
You need some sort of routine, definitely, in my
Mhm.
opinion, but you can decide for yourself what it's going to look like.
Yeah.
I don't have to be ready to get to work at 9.
Mhm.
Yeah.
I can just do whatever I want in the morning and then start at 11 or
Yeah.
something.
Yeah.
Mhm.
And that's just fantastic.
Yeah.
And I could, if it's like Wednesday and I'm feeling tired, I can just take the day off.
Yeah.
Which is amazing.
Yeah. So if you don't.
If you can allow yourself to do that.
Yes.
That is also a struggle of allowing yourself to do that.
Yeah.
That's what you were saying as well.
Mm.
Yeah.
100%. Yeah.
Mhm. maybe you're taking too much time off then.
I don't know. That's not what it feels like.
No, I'm not saying about you, but in general, if you have this liberty, then at some point I think you might.
Yeah, that's definitely.
You don't strike a balance.
But I
every
think
time you
if
get
you're doing a PhD, you have enough drive to sort of. You're feeling guilty for not doing enough for.
Yeah, definitely.
Automatic.
The guilt is there.
Mm.
That's the case.
Yes.
Yeah. So you feel guilty when you don't work.
Yeah.
That's
Yeah, so you're not having fun either way. Just in a perpetual state of.
Yeah.
This is the
stress.
central sort of thing that you need to learn is to allow yourself
Yeah.
to have guilt-free time.
Exactly.
Mhm.
Exactly. And whatever that entails, whatever consequence
Oh,
you have
yeah.
because of it, you deal with it, you
Yeah.
accept that, and you still take that break.
I
Mhm.
think that's also that is true in life in general.
Yeah.
Certainly, can like that's even a balance I have to find at work,
Mhm.
and not just in academia.
Yeah.
Okay.
And I would have one question related to that because we both worked. How do you find the reward that you get out of doing physics? As in, how much reward is there for a physics student? You know, can you just live off the reward that you're, getting from studying those courses, or you definitely need a lot more to your life than just, studying to get through with it?
Yeah, absolutely.
Wow.
I think kind of.
Yeah,
So I think
go ahead.
for me, certainly, the good thing about working was you got there at 8 or you got there at 9, whatever you started, you left at 5:30 or whatever, and then it's your time.
Yeah.
There's no kind of, and I feel like you can probably do that to an extent in PhD as well. There's no kind of like having to kind of, and sometimes you are going to have to do a bit of extra work, to pull a bit of overtime, that's fine. But certainly once I'd become okay with not selling myself to the company, once I was okay with, actually, you know what, I have been here long enough that I don't feel bad about turning up at 8 every day and leaving at 4:30 every day.
Mhm.
And suddenly I could do whatever I wanted in the evening. I could go climbing, I could play the PlayStation, I just had my own time.
You don't feel guilty anymore.
Yeah, I didn't feel guilty,
Yeah.
Whereas I feel like at the moment those boundaries are not nearly as clear. If I start working at 8, I'm maybe taking a couple of hours for lunch, or I'm having breaks here and there, or I'm just working the entire day and still not feeling that good. I think you said earlier, like, you feel guilty for not working, so whether you work or not, you're still not having fun.
Yeah.
You're not.
That's a big aspect,
Yeah.
yes, of just living the student life.
And I think I'm having to, it's a whole kind of like, I'm having to re-figure out that playing part right now.
Might this be because this is the student life, or is it about theoretical physics? What do you think?
I hope it's not student life, personally. I hope it's more something that I'm struggling with in
Because that's what I felt always too.
Yeah.
So I can relate to that definitely.
So you were.
I think I think other people must have this as well, not just theoretical
Mm.
physicists.
Yeah.
Yeah, so I don't know how other disciplines feel about this.
Do you guys think that this is an added element of just not thinking you've put in enough hours, or not getting rid of that lingering feeling of if you've done enough work could be magnified because of lockdown and not being able to move spatially?
That's true, actually.
Mm.
I think that's possibly, maybe if I was able to go onto campus at 8,
Yeah.
then I could leave campus at 4:30,
Yeah.
and I would have that separation of
Yeah,
that's where I
definitely.
work and that's where I play.
Exactly, and then it's like a situation of where you can be stressed in an environment, you leave perhaps for a vacation, perhaps to visit someone. When you leave that physical location, all of a sudden those stresses that were really stressing you out here don't seem that big anymore. I definitely found that in the Christmas holidays. I knew my stresses were very real, but for a second, because my day to day was different, my surroundings were different, it wasn't as magnified. I thought so. That could be having study in your bedroom and then having your bed there and then sleeping as well, looking at that stuff. I think
and that's not good for you mentally anyway.
No.
You're not supposed to work and sleep in the
So,
same
yes,
place.
yes, yes.
There's a lot of kind of guidance to that effect. So yeah, maybe that is true. Maybe it would be a lot easier if we were not confined to a building. Yeah.
But compared to work life, is life as a physics student rewarding in itself? Did it give you the same sort of reward or as much reward as you got in your company? I'll tell myself.
So I guess in that sense, you've got to talk about what a reward is, haven't you? Because obviously
Can be a promotion, can be recognition.
Yeah, so obviously kind of like at my company, I earned a lot more than I do now, considering I'm very negative at the moment.
Yes.
And I think, I mean, at the end of the day, there's a reason I'm here. Right? I'm not here because I was forced here. I'm not here because this is worse for me. I'm here because I get a reward out of doing physics. And again, I'm very aware that I've complained a lot tonight. But again, I wouldn't change this for the world. Like, I think there is an issue. I think there are lots of issues with the way physics is taught, and the way the path we have to lead. But I think, given that this is currently the only real way into physics, I think it's worth taking that chance. Because to me, physics is the reward. I think, I genuinely enjoy physics. I genuinely, it's something that I've always kind of had an enjoyment for. And 100%, it's so much more rewarding being here than it was being in my job.
Wow, okay.
Fundamentally because I didn't care about my job. I care about this.
It's like a personal.
Like, it doesn't matter how much money you get with my job. It just didn't care. And at a point, you stop being able to force yourself to put up the appearance that you can. So yes, 100%, this is more rewarding than my job was.
Very interesting to hear that.
Different way.
In a very different way, yes. So for myself, I was actually surprised how rewarding life can be inside of a company. I mean, doing physics, you're just another physics student, and you're doing your bachelor's project, and you're studying. But apart from your supervisor, that kind of knows what you're doing. Nobody else knows your name. They don't know what you do, what you're into, all this sort of stuff. But working in a company, you feel that you're part of something bigger. Sometimes that gives you the feeling that because it's, I was part of a big corporation, so I never really knew. I mean, I always had a feeling that I don't really know where my work is going, how is it being used in the bigger picture. So I always felt a little bit cloudy. But in terms of, relationships that you strike up with people and the people that you have to work to, you feel that you're doing this work and you're helping this other person, and that makes a big impact for what they do. And then they ask you to do this thing, or maybe it's your team, your bigger team, and they give you this task, you do the task, and you feel that, okay, I contributed to this product is gonna be out on the market in a few months because I'm doing this work, and it all feels very rewarding. And when I think about my experience in the bachelor's, my project is not gonna be used by anybody, of course, because it was not original anyway. Like you said, in the bachelor's, you're not expected to do anything original. However, my partner for that project did something original. Kudos to him. Kudos to him. But then, just coming out of that sort of experience, and I've done a summer internship also. I did something there, but then again, they're not gonna be we had this second year student that did these great things, so now it will not be highlighted in in any sort of meaningful way. Maybe somebody will have to read your work, some PhD student that starts. I mean, that's kind of was the goal for me. I was doing a literature review, but that's the extent to which it goes. It's a PhD student that will join and doesn't know very much, and I've done this literature review so they can use it as a reference. That's it. And I spent 12 weeks on it. But in a company, I spent 1 week on an important problem. Boom, it's done, and your team sees that we are really making progress, and you feel that you're putting in work, and you're seeing progress as you go, and it's a lot more satisfying seeing how stuff evolves in a company because it's so visible maybe. But with physics, it's always quite invisible. Maybe it's at least in the beginning you don't even know if your work is gonna be meaningful to anybody except for you. So
it's interesting actually because everything you say it does resonate with me. Like yes, you have that visibility of you spent a week, you spent a couple of weeks doing something and it's being used and like it's bringing profit. I think maybe there's a bit of a personal thing there, depending on like I guess the reward kind of system is different for everyone. Some
value
people,
system as well.
I think for me, I never, as I said earlier, I never really cared enough about what I was doing at that job. And like, I found it interesting, I did, but I guess for me, what I'm doing day to day has a big impact. Whereas the impact the work has doesn't have so much of an impact on me. So what I'm doing day to day has an impact on me, but the impact that my work has maybe doesn't actually have as much of an impact on me personally.
Right.
So I think because I think you said actually it's true, and I did recognise that and feel that when I was working, but there was still something pulling me back.
Right.
And there was also something pushing me away from that job. Before I came to university, I was looking at other jobs, and actually one of the reasons that I did take the plunge into going back into physics was because every job I looked at was just like, meh, So I think kind of what you value, as you said, probably has an effect there on how rewarding you find different things.
Yeah, definitely. For me, it was a surprise actually that it was so rewarding, and now coming back into it, then again, I wouldn't trade the satisfaction that I get out of just doing physics, but I'm not getting recognition from anybody. Nobody will care actually if my exams will be marked. I mean, up to a certain point. So I'm working this much, and it's for literally some letters on a piece of paper at the end of the day.
I agree with you there. I think there's definitely a social aspect to things and our reward systems and our value systems as well. What you said about your internship as well, and that it didn't really have an effect. I had somewhat the opposite experience in an internship, and perhaps that is maybe that was rewarding because potentially from the social side of things as well. I was received very well. I had strong relationships by the end of it. It was only a month long, and I had formed these very strong bonds with the team. I saw there was the head of the team was a woman, and I really resonated with just having that kind of representation. It was great for me. We had good conversations outside of the work, and it just almost like blossomed because that social side of it was there. And my work, I mean the way it was portrayed to me definitely was that my work was important and it did have an effect. And I mean the whole thing as the whole team and the whole company, or even there were different PhDs positions for that thing as well. So it was definitely that whole thing was based off of benefiting humans in general. So I think that had an element that was there, and I knew that my work was going to be useful in some way. So I think, but I agree with you in the sense that there is a social side of it, and as much as we'd like as physicists and theorists to say, no, I don't really care, I can do this in my room alone and I don't care about the social side of things, I've come to realize that in fact it plays a huge role. and having someone I think that's also, we can circle back to when your teachers cared for you.
Yes.
You could relate to, you were something to them, they were something to you.
Yeah.
Then you almost thrive in that situation, or at least I respond positively to that as well.
Yeah, feelings are big part of life.
Yeah,
Big part
who
of life.
knew? Who knew?
Yeah, it seems so, you know, because literally, you know, maybe some people go into theoretical physics thinking that, you know, they can just be these little robots that are, you know, just working hard, going through.
Being really clever, coming up with these.
Yeah. And at the end of the day, you know, sometimes you really become miserable because of this worldview.
Absolutely. I think kind of, you're right, there's a kind of a stereotype, isn't there, that especially theoretical physicists, but also physicists in general are kind of, you know, loners, and, you know, I certainly kind of, you know, I, at one point in my life, had a bit of, I didn't like to tell people that I was doing physics because of the image that I thought they would then have of me. Actually, the vast majority of people I know in physics are very sociable, very kind of like easy to get on with. But I certainly had that in my head. But I think you're right, like everyone needs some kind of contact. You can't be locked up in a little box on your own. Like, doesn't matter how introverted you are, how kind of how good you are at being on your own. There is a limit to it, and I think you're right. That is incredibly important. I think that's where a lot of our rewards do come from. Why should I just look at that?
As much as we hate presentations and all of that, we still gotta.
So I still turn up to those Wednesday presentations every week because it's nice to see people, you know, and like okay, you don't interact with people, but it's nice to say, oh, okay, here's a group of people doing something. You know, I don't pay attention to half of them.
I can't. I don't understand most of it.
But being there it's a nice little kind of like, oh, there are other people here, you know. They're similar, kind of like I pop down to the study room occasionally, even though I don't sit with you guys because I work better on my own. It's nice to be around people.
Exactly.
Battery is almost gone. So but we only have maybe 5 minutes left. So maybe one question which is pretty important to answer before we end. What keeps you going when things are going tough?
That's an interesting question, actually.
Salah came up with it. I need to give the credit.
Did I? Did I?
Yes.
From our conversation earlier.
What keeps you going?
I think, I don't know, I guess for me personally, there is an inherent kind of satisfaction in physics. Like, as tough as it is, I guess in a way, especially when it's tough, there's still that kind of just really pleasant feeling that you get when you've worked something out, or when you've figured out something new, or when you've learned something interesting. I think for me, those moments are worth the tough, you know.
The intellectual satisfaction.
And I think at the same time, that doesn't necessarily mean I'm not going to try to encourage changes that will make it less tough. I don't think that toughness is inherent, but I think it's worth it given that it's kind of the state of the world at the moment.
I agree. This also connects back to the previous discussion, but just sort of also my self-worth, like in general, is so connected to how well I do in academia. Is that like if I stop doing it, what will be left? First of all, but also like exactly as you say, the feeling you get when you finally something starts working and the cogs start turning. It's just such a great feeling. And you, at least for me, I lose track of that sort of realization that that's going to happen eventually if you're stuck for a few months on a problem. You know.
So you say that.
But it's, in the end, so far it's been worth it. And I think what happens as well is that you're sowing seeds now for sort of the recognition that you might get later. If you do well in a quantum field theory course now, then you will reap the benefits of that later. Like in subtle ways, maybe even ways that you don't see. Or like if you do a great master's project, and then you will meet someone and you will like really like who is interested in that, for example, and that is just like these little moments of recognition, I guess. That's just great.
So.
I think I'd agree to the self-worth and the and I think just knowing that this is tough and the world's people throughout history have been trying to solve these problems and we've built up on this and these are at the forefront of it's a global thing. It's loads of people are trying to solve this and you being one of those people trying to solve something bigger than you, something huge, something that talks or relates to scales of the universe, scales of or vice versa, just the tiniest scales that affects everything else. Working these fundamental truths, working on these is definitely like a reward in its own. And also I would agree with the my self-worth is tied to this. And that's why it's been difficult when you don't do well. It becomes really, really difficult, and then having a lot of your value system placed on this, which I think maybe we need to navigate a little bit better. But I have reasons outside of these as a woman in physics as well. I think that's a huge factor for me, and I think to myself whenever I'm down, a lot of the times not seeing representation or not seeing a lot of myself in the field, I think to myself, if I also quit, then the next Saba will not see a Saba in the field. So to me, that is very important. That is, and to almost humanize. Not that I think that I will be the icon that humanizes physics. It's not so glamorized. But I think the next person who's just as they are in the same position as me, they're also validated. And it's okay to not know certain things and not be as aware of maybe the next person. But you're still on the right track. And if you have a love for physics, then that can sometimes be the drive as well. Even though a lot of things are working against you.
So it's Nesta for your self-worth, Saba for you, it's also being one of the pure representatives of women in physics. For me, I think what really keeps me going is that dream that I had when I was 15.
Nice,
I know it sounds corny as
No.
and that's fine.
But
we all have.
But I think just keeping that alive. I think I've been in it so deep and I feel because I spent so much time doing physics and I didn't do many other things in my high school, in my bachelor's and so on. I feel like I've done so much. I mean, so deep. I've sacrificed so much so that it doesn't make sense to my life to give it up. I mean, it's such a big part of me by the way I'm thinking and the creativity that I sometimes have comes from this. I mean, it's so interlinked with who I am. So in a sense, I've went away from studying physics for 2 years. I realized that there is so much satisfaction that can come out, outside of physics, but somehow, I don't know, I still feel like going back.
Gravity called you back.
Going back, indeed.
Yeah.
So,
what about, is there sort of, you have this image, this internal aspiration for, being a physicist is, something to be aspiring towards? Is that something you guys have?
Yeah.
See, I've actually moved away from that more recently. I think personally, I think part of it is going back to what I was talked about earlier, the way people are have real difficulties when they're disappointed by something. I think more recently, in the last couple of years, I've gotten a bit better at just being happy with the way things kind of like the short term, you know, and like plan for the long term, but and you know, and I'm not saying don't have dreams, don't have aspirations, but I think for me, understanding that actually it's okay if this all goes to pot and I never become a physicist. It's okay.
A more mature way to do
I
it.
think,
for
yeah,
sure.
I think
More
definitely.
mature.
I think just having that kind of like that knowledge that it's fine. You don't have to be perfect. You don't have to make it. Trying is worth it, whether you make it or not. You know.
And in that you might find
like
something that you know
exactly.
that sets you up for the rest of your life. Or...
Absolutely.
So we could talk a lot
Oh,
more about this
God,
topic. Maybe we can do another episode, but thank you guys for joining, and
Thank you.
Absolutely.
yeah,
Thank you
Thank
for
you
hosting
for having
us.
us.
this episode, maybe we